So in the previous class, we have discussed about between the two switches, if we make only one link, if it is failed, no communication. So single point of failure. To eliminate single point of failure, backup links are being used. So once you connect your multiple links between the switches, we call it is redundancy topology. A good thing in redundancy topology is backup is available. But problems is what? Continuous broadcast terms, the multiple frame copies. Layer 2 loops is been forming. So to prevent the loops, we have to configure STP protocol. STP protocol is used to avoid layer 2 switching loops in redundancy topology by blocking a port. To block the port, STP uses STP election process, like a root switch election, a root port election, designated port, or non-designated port, and STP states and STP BPDUs, and STP types and STP drawbacks. So we clearly discussed about STP protocol and how to make a force to make a switch is a root switch by changing of priority values. These things we have discussed. And STP makes each port up to 50 seconds before data is being sent on the port. So to overcome the type of issue, the delay is the problem. To solve the issue, port fast. So port fast is going to making your port is fast. It saves the 50 seconds time, bypassing a listening state and learning state. But port fast is not recommended to configure between the switches. Port fast is only recommended to configure where your end user device is connected. And today, let me continue with one more scenario and let me finish up the switching classes and LAN technologies and we'll start Cisco security. So here I have two switches, switch A and switch B, port number 1. Two switches. Switch A ports are fast Ethernet ports. Even switch B also fast Ethernet port. In switch A have some users are connected and switch B also. Now how switch A users and B users can communicate? Let me make a link between switch A to switch B and it's 100 MB link. So A user, B user can send the data with 100 Mbps. If link is down, no communication. To avoid single point of failure, taking one more backup link, one more link for backup. This link is also 100 Mbps link. So once you have the multiple links, loop will be formed. To stop the loops, we have configured STP. What STP will do? Will block the port, any one of the port. We'll consider port number 2 is a block port. If second link is been blocked by STP means, so data communication happens via first link with how much speed? 100 Mbps. If first link is down, then the block port will become forwarding state. Then data will go via second link with how much speed? 100 Mbps only. If it's also down, no communication. So based upon number of failure chances, we can make a multiple backup links. So I'm taking the one more backup link from port number 3 to port number 3. This is also 100 Mbps link. Right? Now multiple links is there between the switches. Now what STP will do? Will block port number 2 and will block port number 3 also. Two block ports. So STP will make sure only one link is active because of loop will be formed. Okay. So now data communication via first link with how much speed? 100 Mbps. If link is down, out of two, any one port become block port. Any one port become forwarding state. And again 100 Mbps. If it's also down, one more block port will become forwarding state 100 Mbps. So actually between switch A to switch B, we have 3 links is there, but data communication happen only one link with 100 Mbps only. Then how we can share, how we can send the data more than 100 Mbps? Now we have to be combine multiple physical links into one logical link. So 3 links has been combined, then it's create one logical link between A to B. So once you combine the multiple physical links, now full bandwidth you can utilize it. Like how much bandwidth is there in 3 links? 300, 100, like 300 Mbps. So 300 Mbps utilized. And data communication happens via first link also, second link also, and third link also. Means load balancing. Now out of 3, any one link is down. Still you have 2 links, 200 Mbps. Means redundancy is also available. So this process we call the ether channel. Like ether channel combines multiple physical links into one logical links to achieve the full bandwidth for load balancing and to provide a redundancy. So these ether channel generally we can configure between switch to switch, ether channel or port channel we can call. So this ether channel we can configure between switch to switch, switch to router, switch to firewall also. For what? Is combining the multiple physical links into one logical link. Once if we combine the multiple physical links, then complete full bandwidth you can utilize it. It provides redundancy also. And the load balancing also will be done. Okay. Ether channel combines 2 or more physical links into one logical link. The purpose of aggregating link is achieved to full bandwidth, load balancing and redundancy, configured between switch to switch, switch to router and switch to firewall. Like in our example, we have combined 3 links, right? But Ether channel can support 4 links, 5 links, up to 8 links can be support, up to 8 interfaces. The main point is to create Ether channel, switch port needs the same physical ports and same speed. Like switch A ports are fast Ethernet, 100 Mbps ports. Switch B ports are 100 Mbps ports. Switch A ports are half duplex, B ports are half duplex, A ports are full duplex, B ports are full duplex. Switch A ports are access ports. Switch B ports are should be access. If it's a trunk, it should be trunk. Like to create Ether channel, the ports needs these things. Same physical ports, same speed, duplex. Either port should be access or trunk, or port should be in the local VLAN, port should be in the same VLAN, like this. So once if it is been satisfied, then only we can create Ether channel. One side is a 100 Mbps, other side is a 1000 Mbps ports. No, Ether channel will not be created actually. Okay.
All in this person of STP will be in disabled mode or it is enabled state.
STP will work when multiple links, but here only one logical link. Physically 3 links, but we combine into one logical link. No? So between A to B, only one link is there. And STP won't work here. So we can create Ether channel in the 3 ways. One is a static Ether channel, means should be always on. This is manually got configured static. One is dynamic Ether channel. Like between the Cisco to Cisco, switch A and switch B both are Cisco switches, then you can have PAGP protocol. Port aggregation protocol. This PAGP is a Cisco proprietary protocol. It has two modes, desirable and auto mode. This protocol works between the Cisco for dynamic ether channel. Now what about non-Cisco LACP, link aggregation control protocol? LACP is a open standard, two modes, active mode and passive mode, active and passive. Active is similar to desirable, passive is similar to auto. So we can create ether channel in a static method also, PAGP or LACP, like this. See the configuration of ether channel. Interface, the ports what we are combining, the ports you can use the range command, and channel protocol PAGP, channel group. You can use any number, but both switches should be same group number. If it's PAGP, modes are desirable auto mode. If it's LACP, active and passive modes. In two switches, I'm taking two links, link 2, link 3, three links. When you have the multiple links, by default STP is enabled. What STP will do? Will block any two ports. Two ports are block ports. Only it allows only one link for data communication. And this is a LACP configuration, same. Channel protocol, LACP, channel protocol, PAGP. If it's PAGP, desirable or auto. If it's LACP, active or passive. The group number what we have configured, the group number should be same in both switches. See now, switch A ports are green and switch B, two ports are being blocked. You see? Yeah. Now what we are doing is we are going to combine three physical links into one logical link by creating of PAGP or LACP. First PAGP protocol because of Cisco to Cisco. Interface range fast Ethernet 0/1, 2, 3 channel hyphen protocol PAGP channel group, you can use any group number, mode desirable mode. So creating ether channel is means logical link is created. Just logical link is created. Notice the group number have used group number 3. In the switch B also should be make you same. Let me configure the switch B. Interface range fast Ethernet 0/1, 2, 3 channel protocol PAGP channel group. What is the group number? I have used group number 3. Mode. Other side we have configured desirable. Other side is auto mode. One side is desirable, auto. So now we got one log message. Before it is created, now it is what? Interface port channel changed it to up. In switch A also we got interface port channel changed it to up. So first initially the logical link is created, it just created. Creating a port channel means what? Logical link. It's created. Now it is also up after config of both sides. Now if you see in the link, it's going to like all 3 ports will become the green. Yes, have you seen? Now all ports are green color without loops. No, no loops, but still you can configure. We can send the traffic with first link, second link, third link. Load balancing, redundancy means if any one link is down, still we have 2 links, 200 Mbps you can use. Redundancy. These are very good advantages. Switch level load balancing means what? It's the channel. So how exactly your OSPF and RIP like these protocols is doing the load balancing for router and outside of the network? Within internally between the switch to switches to load balancing, we use EtherChannel. Okay. Yeah. So we have done LAN technologies and the protocols like introduction to switch and switch functions, switch types, switch categories, switch configuration, and VLANs, trunking, dynamic trunking, VLAN trunking, VTP, CDP, LLDP, STP, inter-VLAN routing, port fast, and Ether channel. These are all the LAN technologies we have. So which we use real time. These protocols are mostly used in the real time. Okay. So whatever our topics we have done with the CCNA somehow, and we'll be start with the Cisco security with some advanced concepts. Here we are going to discuss about the basic firewall concepts, not firewall, basic firewall concepts. From today onwards, whatever the topics we are going to discuss all comes under Cisco security. Yeah. So here I have one scenario. 3 offices. One is branch 1, head office, and branch 2. I request to everyone, please try to understand this concept first clearly. The scenario, if you understand, subject is very clear. So if you have 3 branches, you try to understand the real-time scenarios, you know, like how the real world is being connected. Branch 1, head office, and branch 2. 3 offices there. As per routing conditions, IP conditions is okay here. This is 1.1, 1.10, 1.20, 1.30, 10.1, 10.10, 10.20, 10.30, and it's a 2.1. 2.10, 20, 30, like this. Okay. Now in head office, let's consider 10.30. This device is a server, file server, or mail server, whatever, FTP server. Yeah. This is my FTP server. Like in head office LAN, branch office LAN, in branch office LAN, let's say there are 200 users is there. In branch office 2, let's consider there are 250 users. And head office 500 users. Simple question is how we can enable communication from this all the LAN users. Branch 1, head office, and branch 2 all LAN to LAN users, how they can communicate. Configure routing protocols. Can be static routing or RIP or OSPF. By enabling of routing protocols, traffic can be moved from one network to another network and they start doing communication. They have access to use the resources. So have enabled RIP protocol in branch 1, RIP protocol in head office, RIP in branch 2. So once if enable RIP, now they'll exchange the routing information automatically and routing tables are updated. Then you can start doing communication. So for all users have access, right? Yeah. So means these all 200 users can have access to use server. Even branch 2, 250 users can have access to server. And 500 users is already there access to first server. Like total how many users traffic is coming to server? 5, 250, 200. Like 950 users traffic is coming to one server. Now how about your server performance? Obviously it's go slow down. Like, like many users traffic is coming to one server means server performance is down. Then how we can improve our network performance? What's the solution? How we can improve network performance? Yes.
Adding the load balancer.
Okay. Yeah. So I have a common question to everyone. So we have internet at your homes, right? We use Wi-Fi router and we used to create passwords. Generally, do we share password to others? No. Why?
No.
security reasons.
Security.
Why we are not sharing the password to others?
Data slow, I think.
Yeah. So if you share your internet password to others, others can utilize your bandwidth. So generally, why you use internet homes? Maybe you are doing work from home, or maybe technically you are doing the something, or maybe attending the classes, you know. So for your purpose is like for education purpose and office purpose, something you are doing for internet. But what others will do, others will utilize for the entertainment purpose. So they are using complete your internet bandwidth, then your performance has been slowed down. So whatever the bandwidth is available, that bandwidth efficiently we have to use for your respective works. Others will what do? They will be making a movies download, they are doing any online gamings. So your bandwidth has been consumed and your network, your performance is slowed down. This is one of the reason only. It is not a primary reason actually. The primary point is if you share your password to others, others is a part of your network. Then what others will do, they can monitor what type of traffic you're doing. Like from your network, you are going to log into your office servers, and maybe you are doing your like a like online payments, like whatever, they can monitor your traffic. Maybe through your network, they can do something. So your network is not secured. So for security reasons, and to improve your network performance, what we are doing in, we are not sharing your password. Means that indirectly we are going to control the users by setting a password, and we are making a limited users only. What do you mean by password creation? If you create the password means what is mean by the main point is what we are controlling the users. That's it. If password is not created, then everyone can access. So 10 members, 20 members, 30 members, everyone can access the free Wi-Fi. They're not secured. Complete bandwidth has been wasted, finished for 2 or 3 days, and therefore your network is slow. So everywhere, anytime, network security means only the one point is limiting the users, controlling the users' access. So by controlling the user access, then your network performance has been improved and your network is secured. The same thing here also. Now 950 users traffic is coming to one server, then server performance is slow, and moreover our network is not secured. Then what we want to do? We want to control the users. From branch 1 out of 200 users, like all 200 users should not communicate, should not, all 200 users traffic should not coming to my server. Like in branch 1, the which user is really required to access FTP server, that user only we can be permit, the remaining all users traffic is been blocked. Same like from branch 2 also, out of 250 users, which user is required to access FTP, that user only will be permit, and the remaining users all the traffic is been blocked. So like this, if we control the user access, then your network is performance is good and your network is secured. So how can control that user means we need to be configure a basic firewall which we call ACL, access control list. Now what is the firewall will do? It's control unauthorized traffic. The same thing ACL will do actually. Whatever access they have, that access is going to controlling by preparing a some list. So what is ACL? ACL is list of a ACL access list or a group of commands configured and routed for what purpose? To control flow of traffic from one network to another network. We'll do instead of 200 and 250, simple example. In branch office 1, have 3 users, 1.10, 20, 30. Now 1.10 user should not communicate. 1.20 user or 1.30 users should not communicate. In branch 2, 2.10 user should not communicate. 2.20 user should not communicate. But my requirement is in branch 1, 1.20 user, yes, you can access my FTP server. Yes, in branch office 2, like 2.30, yes, you can access my FTP server. So like this, we are preparing some list of the rules, group of commands, number of policies, IP address based. Like what is the first rule? So on 1.10 user traffic is blocked. Block means what? Deny. What is rule number 2? Similarly, 1.30 user also denied. What is rule number 3? 2.10 user. Rule number 4, 2.20. And what is rule number 5? 1.20 user. 1.20 user traffic is what? Allow. Allow means permit. Similarly, 2.30 user traffic is also permit. So this list we call ACL. So we are creating the rules. We are writing the policies. Which user traffic is denied and which user traffic is being permitted. That we have to prepare some list. And these all the commands generally we can configure in router. Now what router will do? So whenever traffic is coming from outside, it examine. Every packet is been examined. Like 1.10 user traffic is coming to head office to access FTP. Now, whenever traffic is coming to head office, in head office there is a ACL rule list is there. Now, what head office router will do? Okay, you're coming from 1.10. Let me check my rule list. Yeah, 1.10 you are there. Rule is what? Denied. Then traffic is denied. So when 1.2 is trying to access FTP server, so 1.2 traffic is coming to head office, and what head office will do? Will stop that. Yeah, if you're coming from 1.20, let me check my rule list. Yes, 1.20 is available. Yeah, you are permitted. Then this traffic is being permitted. So router can examine each and every packet whether to drop it or whether to forward it based upon the rule list, based upon the ASX list. So it provides layer 3 and layer 4 security. It is layer 3 network layer. The network layer IP addresses comes under, right? Like IPv4 address, we can we can filter the traffic. I mean, we can control with IPv6 also. That IP address will comes under layer 3. Layer 4 security means what? Transport layer. Transport layer protocols are what? TCP, UDP. So for so-and-so user, like FTP service you want to block. So FTP server should not communicate. So comes under TCP. So what are the TCP services that can be blocked or it can be permitted? And UDP service also. So based upon the service, some service is being permitted, some service is being blocked, like that we can do. So what router will do? Router examines each packet to determine whether to forward it or drop it based upon conditions specified in the ACL. ACL functions, what ACL will do? Control network traffic to improve network performance. If you control the traffic, then obviously network performance is improved. And provide the security also, basic level of security for network access. So ACL not only blocking the traffic, denying the traffic, ACL can deny, ACL can permit, and ACL can permit. What it can permit? You can write the rule. 1.20 traffic is permit for SMTP. Means 1.20 permitted is for what? SMTP. But 1.20 can access FTP? No. He is permit for SMTP. Like selected services, we can be permitted. So can filter the traffic based upon type of traffic. ACL can allow web traffic, unblocks email traffic, or blocks email traffic, allow web traffic, like we can configure actually. So the main point is to control the traffic when to implement ACL, right? So to implement ACL, we should know the ACL terminology. So what is the ACL terminology? Let me explain clearly about 6 very important points. ACL can block the network. Blocking is nothing but what? Deny. What can be denied? What is denied? What we can deny? That is the point actually. Deny means what? Blocking. What we can block by using ACL? A single host, a single computer traffic can be block. So host traffic means only one user, one computer traffic should not communicate. Yes, we can do that. Or entire branch 1 should not communicate. From branch 1, 1.10, 1.20, 30, 40, like all complete branch 1 users should not access. Then what we need to do? Block on the network ID. The whole network we can block. A host traffic we can deny, or the whole network we can deny. If they're using a subnetwork, yes, even the subnetwork also we can deny. Subnet and service, HTTP or FTP service. So we should know what is deny, what can be denied. So deny means blocking, blocking a network, blocking a subnetwork, blocking a host and service. Next point is permit means what? Permit is allowing. What we can allow? Same. A single host traffic we can allow. Network traffic, subnet traffic, and service traffic. 2 points. What is denied? What can be denied? What is permit? What can be permitted? Next. What is source address? And what is destination address? And what is inbound traffic? And what is outbound traffic? Inbound traffic, outbound traffic. So these points are very important points to implement ACLs. What is deny? What can be denied? And what is permit? What can be permit? Source address, destination address, inbound traffic, outbound traffic. Source address means where the request is being started. 1.10 user want to communicate with FTP server. So 1.10 want to communicate means 1.10 is a source. So here traffic is being started. So source address means where request starts. It's source address. Destination address means what? Where your request ends. It is destination address. So to create a ACLs, we should know clearly about which device is source device and which one is the destination device. And where the traffic is inbound and where the traffic is outbound also we should know. Like inbound traffic means, example, like 2.10 user want to communicate with FTP. Then tell me which one is the source and which one is the destination. 2.10 computer want to communicate with FTP server. So which is the source and which is the destination?
10 is the source.
Yeah, 2.10 is a source. FTP is destination. So 2.10 is a source means what? Where a request started. So here data request is being started, data packets is being started. Now this data traffic, the data traffic is it's coming to the fast Ethernet means this data traffic is entering to fast Ethernet. So this traffic we call inbound traffic. Now what fast Ethernet will do? Packet switch to serial port. Now serial port is sending to head office means traffic is leaving from serial interface means going out of the interface. So this here it is a outbound traffic. In head office serial is inbound. In head office fast Ethernet is a outbound. So here we have implement ACL. So on which interface, what type of traffic is it? Inbound traffic, outbound traffic, we should know clearly. 6 points you can read once again.
Balu, I have a question.
Yeah, please.
So usually we hear like inbound DMZ and outbound DMZ in our current environment, right? So what is mean by DMZ, like inbound and outbound DMZ?
Yeah, the DMZ zone will be have the special port in the firewall. So all the traffic will come to outside the traffic will come to inbound DMZ zone. Like there, your traffic is being filtered. The filtered traffic is going to switching to outbound. So in your LAN will become it's a firewall. The firewall connected to router to ISP. From firewall where router is connected the port, and again from firewall it is connected to LAN.
Yes, yes.
Now here we have a separate DMZ zones is there. The ports. Here we connected our servers to the
Okay.
firewall. Yeah. Now from internet, ISP traffic is coming to router and router will check only the routing. One routing is done, will send to firewall. So firewall means it's coming. The traffic is coming, right? Like this is
Yeah.
inbound,
Inbound.
inbound DMZ actually.
Okay.
So what firewall will do? Will check the rules, the rule list. Will check it and filter the
Yeah.
traffic, whether to drop it or allow it.
Yeah.
Once traffic is been filtered, then it will send it to outbound DMZ. So this is outbound. Here to LAN networks is will be happened.
Okay.
Yeah.
Yeah. Got it. Thank you.
Okay. So ACL can filter the traffic. Which traffic can be denied? Network traffic, subnet traffic, host traffic, and service also. Service are what? HTTP service, FTP, SMTP, Telnet, DNS, DHCP. These all are services. These all services majorly comes under two protocols, TCP and UDP, right? So ACL can filter which protocol traffic, TCP traffic or UDP traffic.
Both they can control.
Yes. So ACL can filter TCP and UDP. Not only TCP and UDP, ACL can filter IP traffic and ICMP traffic also. IP traffic means IPv4 user, that the user with IPv6, the traffic also can be controlled. And TCP services can be controlled, UDP services can control. But one of the user is not using my FTP server. One of the user is not using any services. But what that user is doing is he's sending continuously ping traffic. That is also will utilize some bandwidth, right? So one of the user is not utilizing my server and anything, but what he is doing is he's sending continuously ping. So that ping also should not happen. So you want to block that ping request, then you can go with ICMP. ICMP is ping traffic actually. So ACL can filter IP traffic, TCP traffic, UDP traffic, and ICMP traffic also. These protocols. Okay. Here have I two scenarios. The first scenario is (1.10). Second scenario 1.20. The first device, my requirement is first user should not communicate with HTTP server. Second user should communicate with HTTP server. This is my requirement. Now tell me how can write a access list ACL 192.168.1.10. So 1.10 user should communicate or should not communicate? Should not. Means is a permit or is a deny? What is the rule? 1.10 user deny. Which service are you deny?
HTTP.
Port number? Port number. HTTP port number 80.
80.
Yes. So like this, we need to be configure the rule. Access list, so and so user, that user traffic deny when you are using what? Port number 80. So port number 80 is denied for first user. So whenever first user is trying to access HTTP, the traffic is been denied. But my question is, 1.10 user can access FTP service? We deny the HTTP, right? Then what about FTP? What about SMTP? What about telnet? Remaining services can be allowed or not? So remaining services been allowed or denied, we not define anything. What we have configured, deny 80. Okay, port number 80 I denied. What about other services? Remaining services what? So remaining services are whether permitted, whether denied. What we have, what does that mean? So for remaining services, there is no statements. Then what ACL is doing is default is going to deny it. So we need to be permit remaining services. Permit FTP, permit SMTP, permit telnet, permit DNS. Like how many services there? So many services there, right? But here we have to use some operators. That is, if we use access list 1.10 deny EQ 80 means equal to 80. Now can read the statement 1.10 deny which service have to deny? Deny which is equal to 80. It means what? So which is not equal to 80, remaining all services have been denied. I mean, remaining all services are permitted. So we have denied v equal to 80 means exactly port number 80 is denied, the remaining all services has been permitted. Right? Like this we can use. The next case, how we can write the next case? Access list 192.168.1.20 deny 80. Is it right?
No. Permit.
Actually, second scenario is what? Second scenario 1.20 should access HTTP. So HTTP permit means remaining all service to be blocked, right? Then what you want to use means you can use operator call NEQ. Now can you read the statement? 1.20 deny not equal to 80. So deny not equal to 80 means 80 is permitted, then remaining all services are been denied. Like before port number 80 services, you can use LT. Above port number 80, you can use GT. So these operators we use in the real time to block equal to, not equal to, less than, greater than. These operators. Okay.
Less than or better than how they are using? Can you explain one scenario?
Like less than means before, below port number 80 service all are denied.
For the range
Above,
of port numbers.
yeah. Right. Now let's say ACL wildcard mask. How wildcard mask works. Where we have discussed wildcard mask in OSPF, right? It's inverse of the subnet mask, hence it is also called as inverse mask. And point number 2 is a bit value of 0 indicates must match. A bit value of 1 indicates ignore. So wildcard mask works like this exactly. 0 indicates must match, 1 indicates ignore. I'll tell you what is zeros indicates, what is 1 indicates. .255.0.0.0 subnet mask. How can write 255 in binary? 1, 2, 3, 4, 5, 6, 7, 8. 0 indicates 1, 2, 3, 4, 5, 6, 7, 8. So a bit value of 1 indicates, once indicates, ignore. Bit value of 1 indicates what? Ignore. What about zeros indicates? Must match. Okay. Now let's see how subnet mask and wildcard mask works. See, my requirement is I need a whole network. Says 1.0 network and to be denied. So 192.168.1.0. This network I need to deny it. So what happen if I use a subnet mask of this IP? What is subnet mask? 255.255.255.0. What is 255 indicates? 255 indicates once. Once indicates what? Ignore. So ignore the first octet. In first octet, what is the value here? It is 192 or 21 or whatever the number it is there. It should be ignored because of 255. I'm writing it as 0. 255, ignore it. I'm writing it as 0. 255, ignore it. I'm writing it as 0. 0 indicates what? Must match. So fourth octet, what is the value? It should be match. In fourth octet, if it is a 10, it should be match. If it is a 90, it should be matched. If it is a 190, whatever the fourth octet value, it should be matched now. But as per example, it is 1.0. So 0 is there. 0 has to be as it is by match. 0 is there. So if I use subnet mask, actually what I need to be block? 1.0 class C network. What I supposed to block here? 0.0.0. Global at whole 4.3 billion IPs has been denied. This is a problem with the subnet mask. So instead of subnet mask, now if I use a wildcard mask, let's see now how wildcard mask works. What is the wildcard mask of this IP address? 0.0.0.255. Now what is 0 indicates? Must match. So here 0 means your first octet should be matched as it is. I'm writing it is a 192. Second octet 0 indicates must match 168. Third octet 0 indicates must match third octet also 1 dot. Fourth octet is what? 255. Ignore it. Whatever the value here, ignore it. I'm writing is 0. So exactly we have denied our network. So every octet to match, we have to use wildcard mask. Okay, one more problem is, if my requirement is a only single computer, I need to be block, like single host, which is 192.168.1.20 user. This user traffic I want to block. So I have to use wildcard mask 0.0.0.255. First octet is matching 192. Second octet is matching 168. Third octet is matching 8. What about fourth octet? 1. What about fourth octet? 255. Ignore it. If it's ignore means I'm writing is 0. So my requirement is I want to block a single host 1.20. Even if we use wildcard mask also, the whole class C network is been denied. Then how we can block a single host? So irrespective of the class, it can be class A IP, class B IP, class C IP, any classes. For single host, wildcard mask is zeros, all zeros. 0.0.0.0. Now every octet will be match, must match. First octet is matching, second octet is matching, third octet and fourth octet, every octet has been matching. So for a host, wildcard mask is zeros. Wildcard mask for a host is zeros. For networks, class A network, class B network, class C network, we can use this wildcard mask. Okay. Now let's see how wildcard mask ACL how works. ACL works in sequential order from top to bottom. Working of ACL works in a sequential order from top to bottom the list. Like back to our ACL topology, how it works. So this our rule list. In the list we have rule number 1, rule number 2, rule number 3, rule number 4. 4 rules is there, and 4 rules are what? Deny rules. Now, how it works? Works in a sequential order from top to bottom. So from top to bottom, sequential order, rule number 1, 2, 3, 4 like this. Example, 2.10 user want to communicate with FTP server. So traffic is coming from 2.10. 2.10 to inbound, inbound to outbound, again inbound traffic, outbound traffic. Here ACL is there. What ACL will do? We'll check the rule list in top to bottom sequential order. So traffic is coming from 2.10. What is the rule number 1? Rule number 1 is 1.10. So source IP and rule number 1, is it matching? No, it's not matching. Whenever it's not matching, now ACL will go for rule number 2. What is rule number 2? 1.30. But traffic is coming from 2.10, not matching. Now what is the rule number 3? Rule number 3 is 2.10. Yes, traffic is coming from 2.10. Matching. And what is the rule here? Rule is deny rule. Then traffic is been denied. Once match is been found, then ACL will not check further rules. What is rule number 5, 4, 6, 7, remaining rest of the rules, it does not check actually. Why is already match has been found? So in rule number 3, match is found, it does not check further rules. If a match is found, does not check further rules. And one more point is there should be at least one permit statement. Okay.
Balu, can you repeat this? At least one permit statement.
Yeah. So what is one permit statement means? So here 4 rules is available, but 4 rules are what? Deny rules, right? There is no permit statement. Now what happen if there is no permit statement? Now 2.30 user, actually 2.30 user should communicate, right? Should allow. Now when 2.30 traffic is coming to access, inbound, outbound, inbound, outbound, what ACL will do? We'll check the rule list from top to bottom, sequence order. What is rule number 1? 1.10. Source is 2.30. Rule number 1 is not matching. Rule number 2, not matching. Rule number 3, not matching. Rule number 4, not matching. If there is no match, then 2.30 traffic is denied. 2.40 traffic is denied. 2.50, 2.60, like every traffic is being denied if there is no permit statement. It's a very big problem now. So that is why if there is no statement of permit, then remaining all users traffic is denied. So you can read the next point. An implicit deny blocks all the traffic by default when there is no match. Invisible statement. If there is no match, then traffic is been denied. So that's why what we are doing means rule number 5. We make it rule number 5 is permit any. So rule number 5 have configured what? Permit any rule. Right. Now 2.30 user is trying to access. Rule number 1 is not matching, 2 is not matching, 3 is not matching, 4 is not matching. What is the 5th rule? Then permit any. So permit statement is a, then permitted. This traffic is permitted. So there is a point. There should be at least one permit statement. If there is no permit statement, blocks all traffic by default when there is no match. Clear? New entries are automatically added to the bottom of the rule list. So new rules will come into add in bottom of the rule. Can have one ACL per interface as per the direction. Like when traffic is going from one side, can configure only one ACL. In other side, another ACL. Like in one direction, we cannot configure multiple ACLs actually. That's the point. So removing of a specific statement in numbered ACL is not possible. I'll tell you what is that point. Okay. Now types of ACLs. IPv4, IPv6. In IPv4, we have standard and extended ACLs. In standard, we have name ACL and numbered ACL. These are the types of ACLs. So first, let me explain clearly what is the difference between named ACL and numbered ACL. What is the named ACL? A list of rules if we configured with the help of name is name ACL. A list of rules if we configure the numbered is numbered ACL. like these all the rules, 5 rules have configured with the name. Example, ACL, CCNA. So if you use ACL, CCNA, this is name ACL. CCNA is the name, right? Name can be, you can use any name, Cisco ACL, CCNA ACL, your office name, your name, can be any name, is a named ACL. Or if you configure the ACL with the number, like ACL number can be, you use any number. My example, ACL number 25. Rule number 2, rule number 3, rule number 4, rule number 5. Now this is numbered ACL. Then what is the difference between name ACL and numbered ACL is, see here, how many rules is there in ACL? Rule number 1, rule number 2, 3, 4, 5 rules. So 5 rules is configured as per ACL conditions. There should be at least one permit statement. Permit statement is also available. Now everything is going well, like everything is up and running now. But my requirement is after some time, rule number 3 I want to remove from the list. Rule number 3 I want to remove from the list. So generally, what is the command we use to remove host name? What is the command to remove IP address, to remove password? Like a no host name, no IP address, right? No IP routing, no command in Cisco. So my requirement is also I want to remove this rule number 3. Then what is the command? No access list 25, so on, deny. So if we use no command, then rule number 3 is being removed. Not only rule number 3, rule number 2 is removed, rule number 1 is removed, rule number 4, rule number 5, like all rules is been deleted. That is the point here we discussed, the last point. Can read now. Removing of a specific statement in a numbered ACL is not possible. So in numbered ACL, if you use a no command for specific statement, the remaining all statements has been removed. So removing of specific statement is possible in named ACL. In named ACL, it is possible. So that is the difference between name and numbered. In numbered, we cannot remove specific statement. In named, it can be removed, actually. Right? The next point is, what is a standard ACL and extended ACL? Let me discuss clearly. Standard and extended ACL. Standard extended ACL.
Hello, can I ask you a question?
Yeah, please.
So, like maybe I missed the first one. So you're saying like these how these ACLs will be managed for like large group of company? Like if suppose like I work for Amazon, so we have like millions of users and like customers and even network engineers, everybody. So how these will be communicated, like how these will be managed? Because who will add like these many services and everything in the ACLs?
Yeah, there is a dedicated team that is going to configure implementation in routers and switches with using some softwares, monitoring applications and SMTP, SNMP applications and PRTG, MRTG applications. So they are not doing it in all the routers actually. All routers are connected in one dashboard, comes under one umbrella. So if you implement in one device, it's going to replicate into all devices. The same
Oh,
rules like that.
so we can apply that like rules to the whole group so that we can eliminate some time.
Yeah.
Okay.
So what is the difference between standard ACL, extended ACL is, let's say here I have one device and this device traffic I want to block. 192.168.1.10 is this computer IP. By using standard ACL also can deny or extended ACL also can deny. First standard ACL. So by using standard ACL, if I use deny rule, deny command, that's it. Deny 1.10. Now for this 1.10 user, HTTP service is denied. No, not only HTTP, FTP is denied, SMTP is denied, Telnet is denied, like DNS, DHCP, like all services being blocked, all services being denied. Why? By using standard ACL, we given the command is what? Deny rule. Now by using standard ACL, if I use permit rule, permit 1.10, then for 1.10, HTTP is permitted, FTP is permitted, SMTP is permitted, Telnet, like DNS, DHCP, like all services are permitted. So standard ACL, either we can deny all services, either we can permit all services. That is standard ACL works. In extended ACL, what we can do means selected services you can permit, selected services you can deny. Like my requirement is a FTP and Telnet should not access and the remaining services can be accessible. So selected services we can permit, selected services we can deny. That is possible in extended ACL. Either all services denied or either all services are permitted in standard ACL. This is the major difference between standard ACL and extended ACL. Then how your router can understand which ACL is being configured in router. Standard ACL is configured, extended ACL is configured, is based upon the number range. So if you use any number between 1 to 99 is standard ACL. If you use number between 100 to 199 is extended ACL number range. Like standard ACL, access list, number range, standard access number range is 1 to 99. What standard ACL will do? It filter the network, subnetwork and host also. Two-way communication stop. All services are either blocked or all services are either allowed. So filters traffic based upon source IP address. What is this point? Filter traffic based upon source IP address means filters traffic. First tell me the traffic. What is the traffic contains? Traffic means what? IP traffic, IP packet. What is IP packet contains? Yes, what is IP packet contains? IP packet contains source IP address. No? Source IP address. Destination IP. And source port. What is the service are using? Source port number, destination port number, this thing, right? This is IP packet content. Now, standard ACL will filter the traffic based upon this source IP only. It'll just examine this field, source IP field only has been examined. Which ACL? Standard ACL. The standard ACL will not look into destination IP is what and what is the service he's trying to access. So that thing will be not examined. It examine only the source IP. We'll check the source IP column. Okay, you are available in my rule list or not. That is only. Is the point. Filters traffic based upon only the source IP address. It does not check your destination place, what IP is there, which IP is trying to reach, and what is the service is trying to communicate. Doesn't matter actually, only the source IP. If it is a extended ACL, so extended ACL will examine the traffic, source IP it will be checked, and destination IP it will be checked, and what is the service you're utilizing. Like all the fields, all the parameters is being included actually in extended ACL. Every parameter is being examined. Are you coming from where? Are you reaching to which device? So source IP, destination IP, and which service you're trying to access. Your source port number, what is the service you're trying to use, and destination port number. Everything is being examined by extended ACL. Standard ACL is only source, only one column. Extended ACL, source IP, destination IP, and service. So where to implement standard ACL is guideline is closest to the destination side how to implement. Okay, I'll show you the practical now, how to configure. So first let me configure RIP enable in all routers. Will enable communication. Router RIP version 2 172.16.0.0 192.168.1.0 in router 2 10.0.0.0 172.16.0.0 and 17. Last router, router 3 RIP configuration. One 172.17.0.0 192.168.2.0. Yes, the three routers RIP is configured. Now let me assign IP address to end user devices. First user IP 1.10 let me assign. Second user 1.20 let me assign. This is 10.10, 10.20. Here 2.10, 2.20. So computer 1, IP address 1.10, gateway 1.1. Second user 1.20, 1.1. Head office computers. Ten dot 001. Next 10.2, I mean 10.20, one nine two 168.2.10, 2.1. 2.20, 2.1. Now let me check communication. Yeah, from 1.10, ping 192.168.1.10. So this is self ping. Let me check with the destination IP, which is 10.0.0.10 computer. Yes, 10.10 is communicating now, right? 0% loss. Means 1.10 user is communicating now with 10.10, but that won't, I don't want to require that. So 1.10 user should not access my 10.10 computer. 1.10 user should not communicate 10 dot. Means which is a source, which one is a destination?
Source 1.10, destination 10.10.
10.10 is the destination. What is the guideline we have in ACL? Guideline is implemented closest to the destination. Means where we have to configure the rule. We need to configure rule in a R1 router or R2 router.
R2.
Destination is R2. Yes. So let me configure ACL in R2. Access list. ACL number 1 to 99. You can use any number. My example is 25. ACL number 25. Rule is denied. Which user? 1.10 user. Wildcard mask. For a single host, wildcard mask is all zeros. So rule number 1 is done. So at least there should be one permit statement. Access list. Rule number 25. Permit any. So two rules. Now implementation closest to the interface, closest to the destination, which is the closest interface destination, fast Ethernet. So interface fast Ethernet 0/0 IP access group number 25. Traffic is outbound. So like this we can configure standard ACL. Creation and implementation both is done. Now if we check communication from the same computer, destination host unreachable, 100% loss, because your traffic is being filtered. It's not reachable actually because of ACL is there. We clearly defined 1.10 user, traffic is denied. What about 1.20 user? 1.20 user can communicate? Yes. Why? Because we have given permit remaining any. 1.10 only denied, so remaining is permit. What if you don't given the permit statement? Have given only 1.10, but there is no permit statement. Then 1.20 also denied actually, Let me check with the 1.20 PC. 10.0.0.0.10. Yes, I can communicate because of permit rule is there. So like this, we can implement standard ACL with number, and we'll see standard ACL with a name ACL. Same like a numbered also. IP access list. Standard. You can ACL name. Example CCNA. Now I can write the rules. Permit rule or deny rule, source IP and wildcard mask. Deny on source 192.168.1.10. Wildcard mask 0.0.0. Permit any. And implementation. Fast Ethernet. IP access group CCNA out. This is named ACL. Okay. Next, extended ACL. So extended ACL range is what? 100 to 199. Can filter a network, subnet, host and service also. Selected services can be permitted. No? One-way communication is stopped. Selected services can be allowed. Selected services can be blocked. Filters traffic based upon source address, destination address, and service. So extended ACL can filter the traffic based upon source address, destination address, and service also. But what about your standard ACL? Will look into only source IP. Extended ACL will look the three parameters. Okay, the guideline is implemented close to the source itself. We are going to implement that action. Okay. It's the configuration part. You can copy. Here, if we take example of 10.10 user should not communicate with 2.10. So scenario is 10.10 user should not communicate with 2.10 FTP service. Which one is the source and which one is a destination? 10.10 source, 2.10 is destination. Service is FTP, port number 21. So FTP comes under which protocol? TCP protocol or UDP protocol? FTP is a TCP service, right? Yeah. So now I can say access list, ACL number. So selected services you want to block means extended ACL. Extended ACL number range is 100 to 199. Example 123, 123, denied. Protocol TCP. Source address 10.0.0.10. Wildcard mask 0.0.0. Destination address 192.168.2.10. Wildcard mask 0.0.0. Operator EQ service port number 21. Like we can configure extended ACL. I'll show you here. Access list 123 deny TCP 10.0.0.10 0.0.0 68 2.10 wildcard mask equal to port number 21. This is rule number 1. Permit statement. Access list 123 permit IP any space any 2 times any source any destination. Now implementation. Fast Ethernet IP access group 123 traffic is inbound traffic. Like this.
Value on that.
Yeah, please.
For extended access, you have to configure the nearest source. But
Yeah.
you are doing in destination router, nearest destination router.
Source router now. So what is our scenario? 10.10 should not communicate with 2.10.
Okay, now you've configured in router 1 or router 0?
Have configured in 10.network router means router 2.
Okay.
Source. So my requirement is 10.10 user should not communicate 2.10.
Okay.
So this is source. Nearest source is what? Router 2. This here I have configured. Like external days here. So now if you check verification, show IP access list. We have a standard IP access list with the number, standard IP access list with the named, extended IP access list with number like we have configured. Deny TCP host so and so destination equal to port number 21, which is FTP service. Is output. So like this, we can implement ACLs with standard ACL and extended ACL. Okay, any doubts? Yeah, try to practice on ACL. If you have any doubts, let me know it. And tomorrow we'll continue with some more internet related topics. Thank you. Have a nice day.